Today I'm going to show you how to get your RTD temperature sensor to a Micro 800 PLC. In this case, we're using our Micro 850 trainer, and we have added a 2080 RTD2 to it, and that can accept two RTD temperature sensors. There's three things you're going to need to figure out when doing this. One is what type of RTD sensor you need. Second is how to wire it. And third is the scaling. And the scaling did trip me up, so make sure you watch this whole video. Now, as far as which RTD temperature sensor you want to use, the most common one is a PT100 385. And when we create our module and connected components workbench, you're going to see it even defaults to it. After that, we're ready to wire our RTD to the module. We already have a video on the differences between 2-wire, 3-wire, and 4-wire, and I'll put a link to it at the end of this video. But for this, we're going to use a 3-wire RTD since it's the most common. The actual temperature sensor is going to come across terminals 1 and 2 of each channel, and then we have that third wire coming off to number 3. And remember from that other video, this is measuring the resistance of our overall circuit. And if you have a 2-wire sensor, simply put a jumper between terminals 2 and 3. In our case, we're going to be connecting to channel 0. So we're going to put the RTD across channel 0 plus and channel 0 minus. And then the one to measure the resistance to our cabling will go to CH0L. And the easiest way to tell which one is the sense wire is on most RTDs, you're going to have 2 wires that are the same color and one that's different. The two that are the same color are the ones that are measuring the resistance of your cabling. So one of those will go to the minus, the other goes to the sense, and then the other color wire will usually go to the plus. Now we're ready to configure it and scale it in Connected Components Workbench, but it's going to be a lot easier for us to test if we can actually simulate a value instead of me just having to hold my hand here and see if the temperature goes up. And to do that, we are going to use the PLC Tools Sim TRT. And since it's made for simulation right by the PLC, you would consider a 2-wire device. But don't forget this jumper wire right here. You do have to have it. So the 2 blue wires are going to replace the 2 red wires that were on the RTD, and they will go to the minus and the sense. And then my white wire will go to the plus. When you're done, it should look like this. COM to channel 0 plus. And then whatever temperature you want to simulate will go both to channel 0 minus and to the sense terminal. Now we're ready to add it in our Connected Components Workbench configuration. I've already created a program, and if you need any help with the basics of that, we have lessons down in the description, but we're going to double click on the Micro 850, and under our plugin modules, I have this module plugged into the 3rd slot. So simply right click where it says empty, and this is an analog module, and it is the 2080 RTD2. I'm going to select it. And notice it defaults to this 100 Platinum 385. This is by far the most common one. And there is an update rate and a little bit about this, and maybe I'll do a video playing with it later. The lower you make this frequency, the faster it'll respond, but the more susceptible it'll be to noise. And the higher you make this, the slower the response time, but the less susceptible it'll be to noise. After that, we're ready to add a program. So I'm going to open up my ladder program. I'm going to show you how to do this in ladder because y'all would be furious with me if I didn't. But I'm also going to show you how to do it in structured text because this one is a good example of where structured text makes your life tremendously easier. And the reason why is this one has some unique scaling to get you into Celsius. And yes, I will go ahead and take it on and scale it to Fahrenheit for everybody also. But we're going to take our raw data and we're going to subtract 2700 from it. And then we are going to divide by 10 to get the degrees in Celsius. So we can't easily use the scaling instruction that you're used to using. If we bring an instruction block down and we start typing SC, you're going to see our scale instructions here. Neither of these are going to make a really clean way to do this. So we're going to just do some basic math for this one, and it'll be a good exercise for us. So the first thing we actually are going to have to do is we're going to convert this to a real number. If we double click on our global variables and we go down and find it, which our addressing is going to start with _IO because this is an input or output device. And then underscore, you have EM. That's the embedded module. But if we go further down, then we have IOP3. So this means plug-in module 3. And then we have analog input 0. So this is what we're looking for. And notice it's an unsigned integer. And that means we don't get any decimal places. And since we're going to want some precision here, which usually you're going to want with some analog, we're going to need to make it a real number first. So I'm going to double click here, and I'm going to type any underscore to underscore real. And this is going to convert that to a real number. And now we will go find that number, and we are going to put it in raw real. And notice it defaulted to a real number. So we'll click OK. Next, looking at their conversion, we need to subtract it by 2700. So I'm going to bring down another instruction block. And actually, here's a good example. I know all you old school studio people are saying, well, I should be able to type SUB, but it's not there. Because right now I'm in the default view. And the default view, the subtract instruction is simply a minus sign. And I'm going to take that raw real that we just made. I'm going to put it here. And then I'm going to subtract 2700. Now there's an error in what I'm doing, but I just want you to see it. I'm going to put that right back into raw real. And now I'm going to go ahead and hit the build button on that. And notice that we have an error here. And if we double click it, it's going to take it and highlight it right here. It says 2700. Since this is a real number, this does have to be a real number. So this will be 2700.0. That's all we got to do to fix that. Next, we're supposed to divide it by 10 because that gives us 1 decimal of precision. So we're going to bring down another instruction block and we're going to put a slash in. That is our division. And we're going to divide raw real by 10.0. And I'm going to put it back in raw real. Notice I'm just using the exact same number through here because this is kind of an intermediate conversion. I only need to worry about it being a unique number at the end of this. So this gets us to Celsius. So let's put this in there and see how it works. So I'm going to go ahead and download this. And if you need any help downloading your program, or if I went through fast through any of those steps, we have lessons on all that. So go ahead and hit that subscribe button while you're working through your download. And so it comes up with a value of 537.9. And currently I have my sensor wires underneath the 1000 degree Fahrenheit terminal. And if we open up Google and we put 538 C to F, we get a value of 1000.4 Fahrenheit. So this would be your temperature in Celsius, but let's go ahead and convert it to Fahrenheit. And to do that, we're going to take the Celsius number and multiply it by 1.8 and then add 32. So I'm going to disconnect and I'm going to bring another instruction block down and we're going to go get a MUL. Whoop. And yeah, there I go saying MUL, just so you can see what I'm talking about here. If we switch this theme to the Logix theme and then we go over here, we can type MUL and that's multiply. But I've been trying to learn more about the default theme lately because that is the IEC 61131 standard. And so I've been keeping it in it. So in this case, I need an asterisk. That's going to be multiplication. And I'm going to take that same raw real and we are going to multiply it by 1.8. And I'm going to put it right back into raw real. And then I'm going to bring another one down. And this time we are going to add, which is the plus sign. And we're going to take that raw real. And we're going to add 32.0 to it. And this time, just so we can see it on the HMI, I'm going to put it in analog scale. And we'll download that. And now it shows 1000.22. And if I put it on 500, it shows 500. If I put it on 250, it shows 250. If I put it on 100, it shows 100. And if I put it on 32, it's showing 31 right now. But we can adjust that, and there are some really important troubleshooting tools that comes along with this RTD module that I rarely see used. So I've created this playlist right here with that video and the one on the RTD and several other helpful videos for you.